All right, in this lesson we are going to be looking at putting more than one inequality together and then either looking for an intersection if you see the word and in between, or a union if you see the word or in between. And I will kind of talk about those more as we go so that that happens. But in and, both things have to happen at the same time. In an intersection, either or both could happen. Okay? All right, so first of all, I'm going to plot the point, graph the stuff, x is less than or equal to 3 and x is greater than or equal to -2. So first of all, you probably have two sets of number lines on your on your notes. That's because you um, kind of want to do this first, get a rough draft, and then do the final one. Okay, so here we go. X is less than 3. So for this part right here, I would put an open circle at 3 because it's not underlined. And x is less than 3 means to shade all the spots that are smaller than 3, so I would shade this way. Okay? Then x is greater than -2. That would be this right here. Greater than or equal to -2 means I'm going to make a enclosed circle at -2 since it's underlined. And I would go from here and graph to the right. Those are all the spots that are greater than or equal to -2. Again, you can use the trick that you can shade the arrow, shade the direction the arrow is pointing as long as your x is on the left. Okay? Now, here's the trick. Because this has the word and in the middle, the only spots that really count are the spots where the blue and the red overlap. Okay? So the spots where the blue and the red overlap are here, and then there's blue and red everywhere in between until I get right here. There is not both blue and red, but you're going to have that open circle. So what I really care about, your final answer, actually should go from -2 colored in up to +3 and then shade in between. Okay? Because if it's and in between, both things have to happen at the same time, and you only care about where there's an overlap. Okay? So if I were to do this, I'm going to do it in interval notation first. Notice as I work left to right, I start right here being shaded at exactly -2. Since it's colored in, I will do a bracket. And then I continue being shaded, shaded, all the way till I get right here at 3. And 3 is not colored in, and so I will do a parentheses. So that's what it would look like in interval notation. And then in set notation, you're going to go like this. The set of all x, like that, such that, and then you want to tell me where it's shaded. And it's shaded in between -2 and 3. So you're going to go x is in between -2 and 3, and then just be careful about what symbols. At -2, it's underlined. It's colored in, so it needs to be underlined. And at 3, it's not, so it does not need to be underlined. And again, it's shaded. X is greater than -2, but less than 3. So your inequality symbols need to go like that. Okay? All right, here's another one. X is greater than 1. Again, I'll just do a rough draft first. This is just kind of my rough draft to picture this. So x is greater than 1. Open circle at 1 to the right of 1. X is less than -3. So at -3, and less than would be to the left of -3. Again, I have the word and in here. And so because I have the word and in here, I have to look for where they overlap. And in this case, they don't overlap at all. There are no overlaps. And so my answer here actually would be no solution. Okay, and I really should have nothing shaded on my number line because there is no spot where they overlap. So no solution. All right, here's another one. X is greater than 5. So greater than 5 would be an open circle at 5 and shaded to the right. This is just my rough draft. Greater than or equal to -7, so that would mean I would be colored in at -7, and again shade to the right because it's greater than or equal to -7. One more time, I have the word and in here. Because I have the word and in here, I only care about where they overlap. Okay? Again, if you have the word and, you have to worry about where they overlap. This is the part they overlap in. So, when I make my final solution, I would have an open circle at 5, and then I see both blue and red everywhere to the right of that 5. Okay? So, in interval notation, I start seeing shading at 5, but not exactly 5, so I'll do a parentheses. And then everywhere to the right of 5, all the way up to positive infinity, like that. In set notation, I would go the set of all x, such that, and I am shading everywhere to the right of 5. So I would go x is greater than 5, like that. Not underlined, because it is not colored in. Okay? All right, now we're going to switch to some ors. So here we go. This first one, x is greater than 1. So open circle at 1, shade to the right. X is less than negative 3. So open circle at negative 3. I'm going to do this. X is less than negative 3. Open circle at negative 3, shade to the left. Okay? In this case, when you have the word or in here, or means just basically anywhere you see any color at all. Anywhere you see any color at all. And I actually, this is different than what's on your note sheet. Well, we'll do it like this. That's okay. If it's like this, it's anywhere you see any color at all. So when I do this in, this could be my final draft. Okay, this is my final draft of my thing. I could say where I see any color at all, and I would go like this: set of all x, such that, and just tell me x is greater than 1 or x is less than negative 3. Okay? Then, when you do this in interval notation, you have to be really careful because here's the deal. You start seeing shading down here at negative infinity until you get to negative 3. So if we think of just that section, I go from negative infinity, that's a horrible infinity sign, to negative 3, a parentheses. And then in this section, I go from 1 up to 10. So I go 1, or sorry, not up to 10, up to positive infinity. And then, because they are separate sections, you need this U in between that stands for union. Okay? You need the U in between that stands for union. All right, here is another one. X is less than 1. So that's that. And x is greater than negative 3. So greater than negative 3 would go this way. Okay? Again, it's an or in the middle. So when it's or in the middle, you just have to look for anywhere there's any color at all. One color, two colors, it doesn't matter. Anywhere there's any color at all. Okay? So I, in this case, have color on my whole entire graph. So actually, my final draft can just look like that, okay? Because I have at least some color on my whole entire graph, which means that every single spot is a solution. And if every single spot is a solution, that means your real solution is all real numbers. And I would go x such that, remember that you make all real numbers by going x, that funky little e, and then the two lines with an r, like that. So when I need every single number to be a solution, and every spot on the graph is colored in like it is here, that's how you say it. X is all real numbers. Then in interval notation, it is colored in all the way from negative infinity to positive infinity. All right, and then we have a couple more here. This one is a little weird, but you've got a quantity in between two inequality signs. So what you're going to do is you're going to think of this as two separate equations. Okay? One equation, I'm going to take just this part right here and go x minus 4 is less than 2. Okay? And one equation, I'm going to take just this part right here and go negative 5 is less than x minus 4. When they are sandwiched in between, I call it an inequality sandwich like that. I've got a quantity in between two inequalities. You always fill it in with the word and every single time. Okay? So first of all, I'm going to solve this one. X minus 4 is less than 2. I will add 4. And I have x is less than 6. Okay? Fill it in with the word and. And then over here, I'm always going to solve these so that I have my x on the left. So I actually am going to subtract x. I do not need to switch the direction of the inequality because I did not divide by negative. So I have negative x minus 5 is less than negative 4. Add 5. Negative x is less than 1. Divide by negative 1. I divided by a negative. Switch the direction of the inequality is greater than negative 1. Okay? And now, if you were to graph this on a number line, I have x is less than 6, and x is greater than negative 1. And remember, the word we had in between was and. And so because we have and in between, we need to talk about where they overlap. And this is the section where they overlap right here where I see both blue and red. So that really is my only concern. From negative 1 up to 6, shade in between. Okay? So I will go from negative 1 up to 6. Okay? Parentheses at both ends because it's not included. When I do my parentheses, again, it's shaded in between negative 1 and 6, so I'm going to put x between negative 1 and 6 like that. Okay? All right, and one last one. Here we go. I will solve and graph this. So I will subtract 4 from this and have negative 3x is less than 15. Divide by negative 3. I need to switch the direction of the inequality because I divided by a negative, so I have that. Okay, and then over here I will add 3. So I have 7x is greater than 21. Divide by 7. X is greater than 3. Or in between. So here's my rough draft. X is greater than negative 5. Or x is greater than 3. Did I do? Oops, guess, oh no. Okay, or x is greater than 3. So basically in this case, I see color, any color at all. It doesn't matter what color. I see any color at all from right here all the way to the right is where I see any color at all. If it's or in between, that's all you need to worry about is anywhere you see any shading at all. And I see shading from negative 5 all the way to the right. Okay? So in set notation, set of all x, such that I'm shaded where x is bigger than negative 5. Okay? And in interval notation, I'm shaded starting at negative 5, but not exactly negative 5 because it's an open circle, all the way up to positive infinity.